All right, so what I did, I just stopped the other video and I said, I'm not gonna have you watch me put them up there. I put them up there so you don't have to watch me do that. But these are the reactions on the first page. I just wrote these out. It's reaction 1, okay, that's the first one, reaction 2, and then the overall reaction for reaction 3. All right, let's take a look at these. And one of the calculations says, well, write these out, but then we'll find the spectator ions and just use a net ionic equation. Remember, net ionic equations do not include the spectators. Let's go through them and get rid of the spectators. Remember, a spectator ion is something that's the same on both sides. It hasn't changed, hasn't done anything, just kind of sitting there and watching because it's not doing anything. All right, anything in the first one? Boom, water. It appears on both sides. All right, so that's a spectator in the first reaction. In the second reaction, any spectators here? Well, let's see. We have an Na, an Na, okay, it's Cl, and a Cl. And here we have hydroxide. That's, I could have wrote that as an H, but I was being consistent with on the paper. That's hydronium. It can be written as H3O or just H. Either one's an H. So hydronium. So no, okay, that's it now. However, remember, here's the thing. This is Hess's law saying that these are the two partial reactions. So each individual reaction can be done separately, or we can do the overall reaction. And the point was to show that these two the overall reaction is equal to these two reactions, and we showed that by the heat calculations. And hopefully you've done those out maybe at this point. If not, do them soon and see how awesome that we were. So now let's check this out. Remember, these two reactions are occurring at the same time in this overall reaction. That means that these two reactions are really the same thing because they are equal to this. So anything on either side of these two can be canceled out with anything on either side of these first two reactions because they're happening at the same time. Do you see anything from reaction 1 and 2 that can be canceled out? Hydroxide. So hydroxide can go bye-bye. That's on the left and on the right of this reaction, which is really the overall reaction. We're separating them out. Let's see, anything else? I think that's it. Let's look at the bottom reaction. Any spectators here? Yep, we got chlorine, and we got chlorine. Okay, so now let's take a look and see what's left over in the first two reactions after we eliminated the spectators. You, and you. And Hokey, Pete, and Joe. Yeah, and that's what should happen. These are the two reactions minus the spectators, the overall participants that are actually doing something that would be included in the net ionic reactions are right here. They show up in this overall reaction because this overall reaction is equal to the two partial reactions. And that's showing the spectator ions and showing those two reactions up top, 1 and 2, although at first glance they don't look the same as this one. At first glance, these two are like, oh, that's different than this one. But after we eliminate the spectator ions, we can see that the only things left are the things that are left over in the overall reaction part 3, reaction 3. And I believe that's all our calculations that we have to take a peek at. Let's see. I kind of did those one out for you, didn't I? I guess you're just going to copy it right off the board and put it on your paper and go, look what I did. I did that all by myself. Okay. All right. Well, you go ahead and do those calculations out and then answer your questions. And that's your lab. I think we did a great job, lab partner. Once again, I think you're an awesome lab partner. You're pretty much my favorite lab partner. And way to nail it.